Hey guys, Alex here with Serious Goose Games. Welcome back to our Unity Tactics RPG tutorial. Last time we went through and thoroughly cleaned up our code. It was a little tedious, kind of boring, but necessary. Not every part of game dev can be super exciting. Today should be kind of fun though. We're going to make it so that the enemy can move its units around. First, we need to create a new script. So in our scripts folder, we'll right click, create mono behavior script, and this will be called player AI. Double click to open that up. And we're going to start out by adding a public bool called ready to end turn. Before we start going crazy in here, let's hop into player. I'm going to scroll up and we're going to add another public bool called ready to end turn. And this is going to be set to false by default. Now this is going to be useful when we want to automatically end a turn, which our enemies will do automatically, and we will get to doing that for the player later. Now we need to bounce over to Turn Manager, and inside Update, we're going to do if players at active player index ready to end turn, then we're going to call end turn. And now inside end turn, we want to make sure that we set ready to end turn back to false. So players at active player index ready to end turn equals false. Now in the player AI script, we've got some variables to add. First is going to be a private player called player. Then we're going to create a private grid manager called grid manager. Then a private list of units called units. And then a private unit active unit. That'll be the unit that they're actively working through. Because we're using a list, we need to add the using system.collections.generic namespace. Next, we're going to create an enum. So an enum is just kind of a list of values that we can select from. In this case, it'll be the behaviors. So we're going to do public enum, call it AI behaviors. And inside here, we're going to have random, aggressive, defensive, smart, and dumb, which is kind of a mean one, but I couldn't think of a better name. And then under that, we're going to do a public AI behaviors, call it behavior, and we're going to set this to be equal to AI behaviors.random by default. Now inside start, we're going to assign player to be equal to get component player, because this is going to be attached to a player object. So by default, it's going to have a player. Then we're going to grab grid manager. We're going to set that to be equal to player.gridManager. Then we're going to do units.addRange. We're going to add our player.player units. And then we're going to set our active unit to units at index 0. Now the next chunk of this video is going to be a lot of targeting functions. So we're going to start by creating a private unit get target by health. And we're going to pass in a bool called find lowest and set it to be true by default. Next, we're going to create a unit array of enemy units. This will be equal to find objects by type unit. And it wants us to put in an object sort mode. So we're going to do find object sort mode dot none. Next, we're going to create an int called health. This is going to be equal to find lowest question mark int dot max value, otherwise int dot min value. So basically, if we're supposed to be finding the lowest, we're going to set our health to be as high as it can go. Otherwise, we're going to set it to the lowest it can go. So it's either going to find the highest health unit or the lowest health unit. Next, we're going to loop through our enemy units. So for each unit in enemy units, if our unit.owner is equal to player, then we're going to continue to skip it because we don't want to target our own units. Next, we're going to do if find lowest and unit health, so unit.health is less than health, then health is equal to unit.health, and our target unit is equal to unit. I just realized we never actually created our target unit. So underneath where we did int health, we're going to create a unit called target unit to set that to be equal to null. Next, we're going to do an else if, find lowest, or not find lowest, and unit.health is greater than health. We're going to do health is equal to unit.health and target unit equals unit. And then after we finish that for each loop, we can return target unit. So this will loop through all of the units. And depending on if we want it to find the lowest or highest health unit, it will give us whichever one of those we're asking for. Next, we're going to create a private unit called getTarget by distance. And we're going to pass in a unit called fromUnit and a bool called findClosest, and set it to be true by default. Inside here, we're going to do the same thing we did before. So unit array of enemy units, set that to be equal to find objects by type. The type is unit. Sort mode is none. And we're going to create an int called distance. This is going to be equal to find closest question mark int min value, or int max value, int min value, and then unit target unit equals null. Then we're going to loop through all of our enemy units. So for each unit in enemy units, if unit.owner is equal to player, we're going to continue. We're going to do int current distance is going to be equal to grid manager.getHeuristic. We're going to pass in grid manager.getTile, grab our fromUnit.gridPosition, and then we're also going to pass in grid manager.getTile, passing in unit.gridPosition. After that, it's going to be like the if statement we had here. So if find closest and distance is less than current distance, distance is going to equal current distance, target unit equals unit. Then we're going to do else if not find closest and distance is greater than current distance, and distance equals current distance, target unit equals unit. And then at the bottom of that loop, we can return target unit. So now we have two functions to find a target based on its health or based on its distance. But what if we just want to grab a random target? This one should be relatively easy. Private unit get random target. We're going to do our unit array again. Enemy units, set that to equal to find objects by type, type of unit, find object sort mode none. Then we're going to create a list of units called possible targets. This will be equal to a new list of units. Then we're going to loop through that for each unit, and enemy units. If unit.owner is not equal to the player, then we're going to do possible targets dot add unit. After that, we're going to do if possible targets dot count is equal to 0, return null. We're going to do int random index is equal to random dot range, 0 as the minimum, and then possible targets dot count as the maximum. And then we're going to return possible targets random index. So that will give us a random unit to attack. Now the last function we need is if we have a unit that's low health and we kind of want it to run away, how do we find the tile that is the furthest away from enemies? Or maybe we have, like in Fire Emblem, you have thieves who will come in, they'll steal things and then try to run off the map. So a function kind of like that. So we're going to create a private tile called get furthest tile from enemy. We're going to grab a unit array called enemy units, set it to be equal to find objects by type, type of unit, and then object sort mode none. Then we'll create a list of units called enemy list. That'll be equal to a new list of units. And then we'll loop through that array. So for each unit and enemy units, if unit.owner is not equal to player, then enemy list dot add unit. After that for each loop, we're going to create an int called max distance. This is going to be equal to int.min value. And then tile called furthest tile. It's equal to null. Then we're going to do a for each loop. So for each tile in gridmanager.map. It's going to yell at us because it's private. So we'll have to remember to change if not tile.inMoveRange. Then we're going to continue. We're going to skip it. Then we're going to do for each unit enemy in enemy list. We'll do int distance is equal to grid manager dot get heuristic. We'll pass in grid manager dot get tile, our active unit dot grid position, and then our tile. And actually, we don't want to pass in our active unit. We want to pass in our enemy. Then we're going to do our standard if distance is greater than max distance. Max distance equals distance. Furthest tile equals tile. And then at the very bottom, return furthest tile. Now before we continue, let's hop to Grid Manager and set map to be public. And then go back. That should fix that little error here. Next, we're going to create a function to assign the AI behavior based on how many units are left. Now, we could set the behavior differently. If we have a map where like maybe we want the enemy to be super aggressive, we could override that. Later, we could add the logic to do that. But for now, I just want to be able to base their AI on how many units they have. So we're going to do private void check behavior. We're going to do int units left is equal to player dot player units dot count. So if our units left is greater than 25, we're going to set our behavior to be equal to AI behaviors dot random, because that is the most unpredictable and ineffective probably, because it's making its decisions randomly. Then we're going to do else if units left is greater than 20, then behavior is going to equal AI behaviors dot dumb. So there's actual logic happening for the dumb behavior versus just randomly choosing to do things. Else if units left is greater than 15, this is when we start to get defensive. So behavior is equal to AI behaviors dot defensive. Then else if units left is greater than 10. So if we're down to less than 15 units, we're going to start getting aggressive. And then we'll do else behavior is equal to AI behaviors dot smart. So the smart AI is going to, in theory, be more effective at combat. It's going to be a little more cautious with lower health units. It's going to target the lowest health enemies. So basically, if you have any squishies, it's going to immediately go for them, which will make any tanks significantly less useful. Next, we're actually going to handle the movement for our units. So we're going to create a private void called handle unit movement. And then we're going to do if active unit dot is moving. We're going to return. Then we're going to do grid manager dot get highlight range. We'll pass in our active unit dot grid position, active unit dot movement left, and active unit dot attack range. So all that's going to do is mark the tiles as in move range or in attack range. It's not actually going to highlight them because we're not calling, highlight range. Then we're going to get a tile reference to target, set that to null. And then we need a switch statement. So switch, we're going to pass in our behavior. So our first case is going to be AI behaviors.random. If we are set to be random, we're going to grab our target tile and set that to be equal to grid manager dot get closest attack tile. We're going to pass in get random target and our active unit. Make sure I put the right name, target tile. After that, we can break. And then our next case is AI behaviors dot dumb. Now, if they're dumb, we're going to do if random dot value is greater than 0.5f. They have a 50-50 shot to go for one or the other. One option will be target tile is equal to grid manager dot get closest attack tile. We'll pass in get target by health, false. So we're going to try to find the highest health target. And then we'll pass in active unit. Otherwise, we'll do target tile is equal to grid manager dot get closest attack tile. And we'll do get target by distance, false, and pass in our active unit. And get target by distance also needs a unit as an argument, so we'll pass in our active unit there as well. If the AI is set to be dumb, it's either going to go for the highest health target or the furthest away target, both of which are not wise choices. So then we can break that case. Then our next case is defensive. So case AI behaviors dot defensive. Now, if they're being defensive, we want to check to see what their health is. We're going to do if active unit dot health is less than our active unit dot health or dot max health times 0.3f, which is an arbitrary number that I just picked. Then we're going to set target tile to be equal to get furthest tile from the enemy. So basically, if they're low health, they're going to try and flee. Otherwise, they're going to keep fighting, but they're going to target the closest unit. They're going to keep things tight. So target tile is equal to grid manager dot get closest attack tile, get target by distance, and we'll pass in active unit and active unit. And then we can break that case. Our next case is aggressive. So AI behaviors dot aggressive. If we're being aggressive, then target tile is going to equal grid manager dot get target by distance. Get closest attack tile, and then get target by distance. And we'll pass in our active unit and then break. So if they're aggressive, there's really no difference between an aggressive AI versus the defensive, not low health one. It's just if they're low health, defensive gives them the option to run away. And obviously none of this is final either. We can go through and change and tweak these and modify the behaviors of each one individually. But for now, it covers what we need it to. Next, we're going to do our last case, which is AI behaviors.smart. And the smart AI is going to target the lowest health enemy it can. So target tile is equal to grid manager dot get closest attack tile. We're going to get target by health and pass in active unit and then break. So there's our switch statement. Outside of that, we're going to check if target tile is not equal to null. Then we're going to grab a list of type tile called pass, and we're going to set this to be equal to grid manager dot get path. We'll pass in grid manager dot get tile, and then our active unit dot grid position, and then we'll pass in target tile, and then we're going to grab active unit dot move to. If it can't find a target tile, then we're going to set its movement left to 0. The last function we want to make is going to check our unit and make sure it's done for the turn. So private void check unit. Inside here, we're going to do if. Inside here, we're going to do if active unit dot movement left is less than or equal to 0. Then we're going to do units.remove active unit, then grid manager dot reset grid highlights. We're going to check if units.count is greater than 0. We're going to do active unit is equal to units at index 0. Otherwise, player dot ready to end turn equals true. And then at the top of this function, before we do our if statement, we're going to reset grid highlights. So grid manager dot reset grid highlights. Because even though we're not highlighting the ranges, we're still marking them, which means if we move our cursor over them, it's going to make it so that they highlight the color that they're set to be, which isn't what we want. So we're going to reset them every time. So the last thing we need to do in this script is go up to update, and if player dot is player turn, we're going to check behavior, we're going to handle unit movement, and then we're going to check unit. Now, because units can die, we want to make sure we're updating this list and keeping it updated. So we're going to go to turn manager again. Inside end turn, we're going to clean things up a little bit. We're going to grab a player reference called current player, set this to be equal to players, active player index. And then we can replace players active player index with current player. But because we're doing that, we need to make sure that we are setting current player again. So after we change our active player index, we're going to set current player is equal to players active player index. And then after we mark ready to end turn as false, we're going to do if current player dot get component player AI. So if they have the player AI component, meaning they are a computer controlled player, we're going to do player AI called AI is equal to current player dot get component player AI. You do AI dot units dot clear, which is we're going to have to make that public, and then AI dot units dot add current player dot player units. So let's hop back on to player AI, change our units from private to public, and then save all of the code and head back to Unity. So I have an error right off the bat in Turn Manager on line 55. Let's check that. Here it is. So AI.units.add, it needs to be add range. So save, head back. So inside Unity, let's grab our enemy player object. We're going to attach our player AI script to it. And then I'm going to grab our enemy unit and I'm going to duplicate it a whole bunch of times. Like our 3 little guys are never going to be able to take out that many units, but they could if they really tried. So because we created all those units, we need to make sure that our enemy has them in its list. So I'm going to clear its list real quick. And then little Unity trick. In the inspector at the top, there's a little lock icon. Click that lock. And I'm going to click our first enemy unit in the hierarchy. Hold down Shift, click my last one, and drag them onto the player units list for the enemy object in the inspector. And that will add the entire range. Then I can unlock and it will function as normal. So now if I save my scene and hit play, we see I have a slight problem. I might have overestimated the size of my map. So let me just make sure I've got the right units selected. Okay, so all of these guys on the edge right here. There we go. Now if I hit play, all of the enemy units are placed on a grid. So if I end my turn, we can see that nothing happens, and that's because we have an error, and that's my bad. If we go to our player AI script, get target by distance, I'm checking if our distance is less than current distance or greater than current distance. These are backwards. So I'm going to just flip the signs, save it, head back, and we should be good to test. Okay, so I will end the human turn, and now we can see the enemy units doing their thing, just moving along. If I move my units, you can see the enemy units moving and doing their thing. So I wouldn't call this the most sophisticated AI, but it does the job for now. In theory, it places each unit in position for attacking, which is what we're going to tackle in the next video. Once the enemy units can attack us back, we basically have our core game loop down. We still have a ton of other mechanics to add on top of that, but really with the base down, adding to it is pretty easy. That's all for today though, so if you like this video, make sure you like and subscribe to help out the channel. Let me know in the comments, how do you prefer your combat? I'm probably going to take the Fire Emblem approach and make it so units trade blows. Some units can attack multiple times based on their speed. I know a lot of tactics games don't really have counterattacks. XCOM was pretty cool with the Overwatch system though. That might be neat to try and incorporate. As always, thanks for watching. I'm Alex with Serious Goose Games, and I'll see you in the next one.